Have you ever wondered about the looming global issue of drug-resistant bacteria? How these tiny, microscopic organisms are outsmarting modern medicine, leaving us vulnerable to once treatable infections? Today, we're peering into the world of antibiotics and the fight against drug-resistant bacteria, focusing on an exciting development that's been more than half a century in the making. In a pair of papers published in Nature, researchers from Harvard University and Roche, a Swiss-based pharmaceutical company, have introduced a new experimental antibiotic. This isn't your average drug. It combats one of the world's most notoriously drug-resistant and deadly bacteria, and it does so with a method that's never been seen before. This new antibiotic, known as Zosurabalpin, has the potential to open up an entirely new class of drugs, offering hope in the battle against drug-resistant infections. The development and testing of Zosurabalpin unfolded in an exciting chronological sequence. An international team of researchers, led by Michael Lobritz and Kenneth Bradley at Roche, first identified a precursor of Zosurabalpin through an unusual screen. They searched through a collection of 45,000 bigger, heavier compounds called tethered macrocyclic peptides, or MCPs, which were screened against a collection of gram-negative strains, including an Acinetobacter baumannii strain. After a group of compounds knocked back the bacteria, the strongest contender emerged with the scientific handle of RO7036668. This molecule was then optimized and fine-tuned, including charge balancing, to make it more effective, soluble, and safe. The result of this optimization was the birth of Zosurabalpin. In further experiments, Zosurabalpin showed its might. It proved effective at killing a collection of 129 clinical crab isolates, many of which were difficult to treat. The experimental drug was also successful at ridding mice of infections with a pan-resistant A. baumannii isolate, meaning however the drug worked, it could bypass existing resistance mechanisms. The focus then turned to understanding how Zosurabalpin worked its magic. The researchers discovered that Zosurabalpin fights off the gram-negative bacterium carbapenem-resistant Acinetobacter baumannii, also known as crab. This bacteria often strikes hospitalized and critically ill patients, causing deadly infections worldwide. It is extensively drug-resistant, with ongoing emergence of pan-resistant strains around the world. Mortality rates of invasive crab infections range from 40 to 60%. To summarize, the key points of this video are the development of a new antibiotic, Zosurabalpin, and its unprecedented method of combating drug-resistant bacteria. The potential impact of this discovery is immense. It may just end up being the urgently needed drug for invasive crab infections, and it could lead to a new class of antibiotics. It's been more than 50 years since the Food and Drug Administration has approved a new class of antibiotics against gram-negative bacteria. But with Zosurabalpin already being tested in clinical trials, the future looks promising. This could be a game-changer in the fight against drug-resistant bacteria and the dawn of a new era in antibiotic therapy. Stay tuned as we continue to follow this groundbreaking story. The world of antibiotics is on the cusp of a revolution, and we're here to bring you every step of this exciting journey.